The fourth lecture video on rotational motion will discuss centripetal force. The centripetal force is a force acting on an object when the object is in circular motion that causes the object to move in a circular path. The centripetal force is directed towards the center of the circle. You may have also heard of the centrifugal force. The centrifugal force is not the same thing as the centripetal force. The centrifugal force points in the opposite direction of the centripetal force, so it points towards the outside of the circle. The centrifugal force is actually an imaginary force, so we aren't going to discuss anything else about the centrifugal force. The centripetal force is the reason why, if you have a bucket full of water, you can rotate that bucket in a complete circle upside down, and the water doesn't fall out of the bucket. If we want to solve problems involving the centripetal force, we can use the equation F sub c equals m times v squared divided by r, where F sub c is the centripetal force, m is the mass, v is the velocity, and r is the radius of curvature of the path of the object. Let's take a look at an example calculation involving centripetal force. A truck of mass 3,120 kilograms follows a curve with a radius of 33.0 meters with a speed of 18.0 meters per second. What centripetal force is exerted on the truck while rounding the curve? It is worth mentioning that whenever we are solving a centripetal force problem, the velocity must either be in feet per second or meters per second, nothing else. Otherwise, the units won't work out for centripetal force. Before we start substituting numbers in, let's write down all of the information we were given. The mass is 3,120 kilograms. The radius of curvature r is 33.0 meters. The velocity is 18.0 meters per second. We are trying to find the centripetal force F sub c. The basic equation for centripetal force is that the centripetal force is equal to the mass times the velocity squared divided by the radius. Since this is already written in terms of centripetal force, it is also our working equation. Next, we can substitute, so we have centripetal force is equal to 3,120 kilograms times 18.0 meters per second squared divided by 33.0 meters. This means that the centripetal force exerted on the truck while it is rounding the curve is 30,600 kilogram meters per second squared, or 30,600 newtons. The pavement on the tires is what actually exerts this centripetal force, since the centripetal force acts towards the center of the circle or the radius of curvature. You can almost think of the centripetal force like a normal force, where the normal force pushes up on your feet if your weight force acts downward. This concludes our discussion on the centripetal force.